All right, good morning, good afternoon, students. We are going to start chapter 5 today. I'm sorry I am not here with you today. My son is sick, so I am at home with him. Chapter 5 is all about thermal energy and heat. And this is a pretty short chapter, so we're going to go through this one real quickly. We're going to finish up by the end of the week and have our quiz on it on Monday next week, so please be prepared for that. In our last chapter, we learned about energy and that energy has different forms and that those forms of energy can transform into one another. In this chapter, we're going to focus on just one of those forms of energy, thermal energy. Today's lesson number 1, is temperature, thermal energy, and heat. Our learning targets for today are number 1, I can define temperature, thermal energy, and heat. And number 2, I can explain how temperature, thermal energy, and heat are related. What is temperature? You probably think about temperature being how hot or how cold something is. Or maybe you have used the thermometer to take your temperature when you were sick. Temperature is a measure of how hot or cold something is compared to a reference point. One reference point that's used is the freezing point of water. That's how the Celsius scale was developed. But what makes an object hot or cold? Remember we learned that all moving objects have kinetic energy. Well, all the particles inside matter are constantly moving around. So all of those particles have kinetic energy. Temperature is a measure of the average kinetic energy of the particles in an object. As an object heats up, its particles move faster. They have more kinetic energy. So both average kinetic energy of the particles and the temperature increase. As something cools down, the particles slow down, and the temperature and the kinetic energy would decrease. So we use temperature scales to measure temperature. And in the United States, we use the Fahrenheit scale, and really no other country uses that. Mostly the rest of the world uses the Celsius scale. And scientists also use a scale called the Kelvin scale. Now, the Fahrenheit scale and the Celsius scale are broken up into degrees. The Kelvin scale is broken up into kelvins. As I said earlier, the Celsius scale is based on where water freezes, so we designate 0 to be the temperature water freezes at. We can see in Fahrenheit that's 32 degrees Fahrenheit, 0 degrees Celsius, and 273.15 Kelvin. And at 100 degrees is where water boils in the Celsius scale. 212 degrees Fahrenheit would be water boiling in Fahrenheit, and 373.15 Kelvin. Kelvin has something called absolute zero. Well, there you can see that there's an equivalent on Celsius and Fahrenheit scale as well. But absolute zero is the lowest possible temperature. Absolute zero is where all the kinetic energy has gone. The particles have no more kinetic energy, so they stop moving. And that we call 0 Kelvin or absolute zero. All right, let's look at figure 1 in your textbook. It's on page 137. Here we see a chart. It is a weather report, but it does not identify the temperature scale. Explain why this would mean something different in Japan than it would in the United States. Well, in the U.S., where Fahrenheit is used, this would mean cold weather because 25, 26, 24 degrees, that's all cold weather below 32 degrees, which is freezing. In Japan, where Celsius is used, this would be warmer weather. Let's fill in the thermometer to show one of the temperatures in Celsius. I'm going to choose 24 degrees. So if I fill in my thermometer here up to about 24 degrees, this is going to be about 77 or 78 degrees Fahrenheit. So what is thermal energy? If you recall from last chapter, thermal energy is the total energy of all the particles in an object. That includes the kinetic and potential energy of all the particles. Now, this is different from temperature because temperature is a measure of the average kinetic energy, whereas thermal energy is the total energy of all the particles. So remember, in averages, you add up everything and divide by the number. We're not doing that for thermal energy. It's just the total, everything added up together. There are two main factors that thermal energy depends on. One is the temperature of an object, and the other is the number of particles in it. There is also another factor, how those particles are arranged has to do with thermal energy as well, but we're not going to focus on that in this lesson. We're just going to focus on the temperature of an object and the number of particles in it. Those are the two main factors that are going to determine how much thermal energy an object has. So, for example, we might have two big things of tea. We might have two 1 liter pots of tea. That's a warm beverage. So let's talk about that. If we have two 1 liter pots of tea and they have different temperatures, the pot with the higher temperature is going to have more thermal energy. Now imagine you have just one pot of tea and you have 1 cup of tea. And if they're at the same temperature, the pot of tea is going to have more thermal energy because there are more particles in it. The cup of tea has less particles. Let's do the apply it on page 138 in your textbook. The total amount of energy an object has depends on its temperature and how many particles it contains. So first off here, in the top two panels, we have some pies. Circle the chicken pot pie that contains more thermal energy. So in the first one, we have a 100 degrees Celsius pie and a 200 degrees Celsius pie. The 200 degrees Celsius pie has more thermal energy because it's at a hotter temperature, a higher temperature. In the second panel, both pies are at the same temperature. They're both at 200 degrees Celsius. But this pie has had some removed, so there's less pie here, there's less particles. So the whole pie has more thermal energy because it has more particles. In part 2, we're going to draw in and record the temperature of these pies that have more thermal energy than the one on the left. So if the pie on the left is at 200 degrees Celsius, we could make a pie that it has more particles and is at 200 degrees Celsius. That would have more thermal energy. We could draw a pie that has the same amount of particles but is at a higher temperature. That would have more thermal energy. I'm going to put this at 225. And then we could draw in one that is both at a higher temperature and has more particles. That would also have more thermal energy. Okay, what is heat? You might think that an object contains heat, but it doesn't. Objects contain thermal energy. Heat is the transfer of thermal energy from a warmer object to a cooler object. Heat always is measured in energy units, joules. Same as last chapter, joules. When thermal energy is transferring in the form of heat, the warmer object will transfer thermal energy to the cooler object until both objects reach the same temperature, and then heat stops transferring. If you touch something that feels warm to you, thermal energy is being transferred to you. If you touch something that feels cold to you, thermal energy is leaving you and transferring to that object. Let's look at figure 2. When you hold your hand over a plate of food, you will feel warmth if heat transfers into you and cold if heat transfers out of you. We're going to draw arrows to show the direction of heat transfer for the foods. So here up at the top, it looks like we have a pitcher of lemonade. Heat is going to transfer to the lemonade from our hand. Our hand is warmer than the lemonade, so thermal energy will flow. Heat will be transferred to the lemonade. And on the grill here, we have some items being grilled. Heat is going to transfer to our hand away from the food because the food is warmer than our hands. And depending on how you look at these other ones here, let's say this one is the sour cream. The sour cream is probably cold, hopefully. So heat will transfer to the sour cream from your hand. Your hand is warmer than the sour cream. Thermal energy will transfer to the sour cream. And then finally, the grilled chicken on the plate here, I think that's grilled chicken, is probably warmer than your hand, so heat will transfer to your hand there. Okay, please complete the Assess Your Understanding on page 139. Number 1A, what are 2 factors that determine an object's thermal energy? Well, we talked about the temperature of the object and the number of particles. Number 1B, object A has less thermal energy than object B, but heat flows from object A to object B. What conditions would make this possible? Well, object B has lower temp, but it must contain more particles. This would make it have a greater thermal energy. All right, so for your notebook, we should be on page 86 and 87. I would like you to please put the vocab page on 86. Leave 87 blank just for now. And then please put the notes on page 89. I know this seems kind of weird, but we are going to do some other things on those pages. And please make sure that you are starting on page 86 and 87. If your pages are not in the right order or number, please clean up your notebook, find the fresh page where you start, where there's no other pages the rest of the way back. Start renumbering at 86 and 87 and get your notebook ready for chapter 5, please.